All right, we are going to introduce how to create an equation of a line given different kind of situations. And they're all going to be very, very similar, actually, even though the kind of information that they give you is going to be different. About the only difference with each one of these types of problems is going to be how you find the slope associated with it. Other than that, once you find the slope, it's exactly the same process. Okay, so a quick couple things that some terminology we want to make sure that we're familiar with is this this slope intercept form is typically the form that we want most of the equations in. And so we're looking at a y equals mx plus b is the slope intercept form. This point slope form is a method, it's a formula basically to help you take a certain amount of information and create this in the end. So it's basically this will manipulate to this. These little subscripts that we have on it, that represents, you're going to sub those out with a coordinate. So this would be like your x1 and that would be your y1. So you would plug them in to those locations. And that is not an x. Sorry, that is an m for slope. Okay, so we'll walk through that process and kind of show you what it looks like. And then the standard form is sometimes when equations, they don't quite look like this, where you have to manipulate them. It looks like this, where the capitals refer to, you don't have any fractions or decimals. So like an example of it would be like a 2x plus a 3y equals 12. Something like that. So that's called standard form. And typically we adjust that out of standard form into slope intercept form because most of the time we end up graphing these types of equations. But there is a value on certain types of things that it's good leaving it in this form, but graphing is not one of them. If you're graphing, you're going to want to manipulate into this because that's typically the most straightforward way of graphing a linear equation. If there's other things that you're doing, very well may be in your best interest to leave it like that. So, so here's the idea that we are trying to find this equation of a line passing through this point with this slope. Okay, so there's only going to be one line. So in general, if we kind of did a quick little rough sketch of it, that if you had some point of 1, 2, 3, -2, and you had this slope to it of up 2 over 3, there's only one line that is going to exist for that. And so there's an equation for that line, and that's what we're trying to figure out. So how do we go about doing this? There's two approaches, and it doesn't matter. You got to figure out which one you're comfortable with. If you want to use the formula, here's the idea behind it. So if we use this point slope form, and it's really more of a formula than it is a form. Our form looks like this: y minus y1 equals m times x minus x1. The idea is if you're given a slope or you have a slope and a point, this is a perfect formula for you. Then your x1 and your y1 are coming from this. So this is our y1. So it'd be y minus -2. Okay, so that value is our y2 equals your slope, 2/3. And then it would be x minus the x value, which is 3. All right. So your first step is always sub in what you know. If you know a point and a slope, that's perfect. That's why it's called point slope form, because you know a point and a slope. All right, so sub in, replace those things. Then it takes exactly 2 steps every single time, and they're the same 2 steps every single time. One of them is get rid of your parentheses by doing distribution. Okay, so if we distribute this, and I'm going to clean that up at the same time, minus a -2 is really a y plus 2. If you distribute 2/3 to x, you get a 2/3 x. If you distribute 2/3 to a 3, it's going to be 3 divided by 3 is 1 times 2 is 2 with our minus sign. Okay, so step 1, get rid of parentheses. Step 2, get y by itself, because we're looking to create this. So we're going to take that 2 and we're going to bump it over to the other side. And so we have y equals 2/3 x, and then a -2 and a -2 make -4. Okay, and that would be the equation. So we have a y-intercept of -4. So if I graphed that actually perfectly, this thing could be hitting a -4 for y-intercept, and then we would be up 2 over 3, up 2 over 3, and that would be our graph. Okay, so that's one way to do it. The other way to do it is just using slope-intercept form right from the get-go. Slope-intercept. So basically just using this. So what we mean by that is, here's what it looks like. We're going to plug in what we know. Well, we know the slope, but we don't know the y-intercept. That is not a y-intercept, right? Because if I graphed it, it's not on the y-axis. And I don't know what the y-intercept is. So far, I would be sitting with y equals 2/3 x plus b. Okay? So where do we go from here? That's where the point comes in. You have a sample x and y that go together. So you could replace the x and the y here. So your y would be a -2. Your slope is still 2/3. And the x value from your sample is 3. What you're missing is the b. Well, now you just created an equation that you can solve for. So if you do 2/3 of 3, it's 3 divided by 3 times 2, which is 2. Subtract your 2 over, and we have a -4 equals our b. And that's exactly what we needed. So now, take everything that we know. We know our slope is 2/3, and we know our b value is -4. And that is our equation. Okay, so you have 2 different methods. If you want to use this formula, then it's just subbing in what you know. Once you have a slope and you have a coordinate, sub it in, and then your manipulation is always the same. Get rid of your parentheses by doing distribution, and then bumping that piece over to isolate the y. If you're doing slope-intercept, plug in what you know, which is a slope, and then they're almost always, well, they are always going to give you a point, so then you can replace your x and your y, and then just figure out what your y-intercept is by solving for b. And then once you have your y-intercept, you have everything you need. You needed the slope and you needed the y-intercept. So that's everything you need for the equation. There's pros and cons for each. The one bad thing about this, you have to remember a formula. And if you don't remember the formula, it kind of makes it a little more challenging. But if you can remember a formula, the math is pretty straightforward. The same process every time. The thing I like about this one is that it's kind of, I don't have to remember anything new. I'm typically pretty comfortable and familiar with the slope-intercept form. I just have to realize that I'm going to have a slope and a point, and I'm always going to be missing a y-intercept. So that's what I'll do I'll do the math to try to figure that out. And then don't forget that you're not finished here. You need the actual equation. So that is your y-intercept. Throw it into the equation to finish it. Okay. So we have some others that are going to involve given different information, talking about what if you didn't know the slope, you're just given points. What if you were talking about a line that's going to be parallel to another line, or a line that's perpendicular to another line? And that'll be a couple other videos to go through those types of problems.